This conference will now be recorded.
Cool. Hey guys, good morning. And last session we discussed about the namespaces, right? A namespace is for a virtual cluster. Let's say it's a virtual cluster which we can deploy the like as related to specific environment applications or related to specific team applications or whatever we are doing. Okay, we can using this case same Kubernetes cluster and we create a on top of it we can number of virtual clusters and we can grouping the two those applications we can deploy in the specific namespace. Okay, that's what we are discussed. And check this, get notes, our notes ready. Yes, this is the namespaces which we created and we have saw that test namespace, mounting namespace, blah blah things we are done, right? Okay, that's it. Okay, this is the done. Fine. The next what we do, let's discuss about the today is a very important topic. Okay, like discuss about the Daemonsets. Okay, it's a very important one. It's a very simple concept. Daemonsets. Okay, now as of now what we saw that basically if you draw the diagram, you have a Kubernetes cluster, you have a nodes, 3 nodes are there, and there is a application, there is a app1 manifest file. We deploy the app1 manifest file. What happens? We are not sure like as which application is deployed now where. Now let's say the app is want to deploy 3 times. Maybe it's deploy like this. The application will be deploy app1 application want to deploy in the 3 times, let's say. App1 application is deployed to 3 times. This is the node 1 and this is the node 2. This is the node 3. Node 3. And we are not sure like as guarantee on the every node your application will be run for each node. Correct? Means this application you are not sure about that. If you mention 3 replicas and it will deploy the 2 replicas in the one node, 1 replica in the another node, or maybe these 3 replicas in the 3 nodes, we are not sure that scheduler will be take care of the call to where need to be deployed. But some scenario, some requirement, you had a requirement for the application, you don't want to mention the how many replicas you want to maintain that app2, and this app2 should be run on the every node. Let's say I want to run this, I want to run this, I want to run this also. Means this app2 should be run on the every node. Every node. App2 will be should be run on the every node. Even though one more new node will be added into my cluster. One more new node will be gonna add in the cluster automatically. Automatically I want to deploy the this app2 application in the my node. Means there is a scenario you have to be run for the application should be run on every node, each and every node. In these situations we are going to use for the daemon set. What we are going to use? The daemon set we are going to use. Why? Because now basically this daemon set is same like as a job, like same as a pod, let's say, and this will be running for the each and every node. If the node will be go down, that daemon set pod will be go down. The daemon is a daemon set also is kind of a pod only. Okay, but what are specific, what are the like as more functionality will come here is basically if something goes down for the in the node, one node will go down, the pod will be also will go down, and the next when new node will come up, automatically the pod will be deployed in the new node. the pod will deploy in the new node. That is the feature of the daemon set. Means, like for example, let's say, now tell me one thing, which is a scenario I want to run the application in the every node. Any scenario means, and what are the Linux system we had? Every Linux system I want to deploy some application. Any scenario? Whatever we discussed till now. Have you guys have seen any scenario? Any Linux mission? I want to deploy my application because something to do some operation. Any scenario you guys have seen, guys, till now? Guys, come on fast. Java installation. This is not installation on the node, dude. Okay, it won't do anything in this. It's running as a container. That is for for Kubernetes, like sorry, Ansible. Maybe it's may needed that it's not a mandatory for us. This is running on the container. Leave it about that configuration level. Okay. Think about one guy should be running on the every node. That guy should be do some job. Understand, na? My requirement. Docker, Docker also it's every node when you install the creator node, it's automatically come up with the automatically. Let's say even that also not the point. We are not installing anything, man. We are not installing anything. Application, application. Any. Now, when you come to that, the previous sessions we discussed. You remember there is a Prometheus server, and there is a Prometheus server, and there is a nodes are there. Each node exporter should be run. The node exporter will be send the logs to the Prometheus. Node exporter will send the Prometheus. N number of server will be created. N number of server node exporter should be running on the every node. Right? Clear na? Because in this node I want to run the node exporter. Node exporter, node exporter. Clear na? This node exporter I want to be run, and then that will push to the logs to the Prometheus server. Prometheus server will be, it will be process your logs, and the Grafana will be show for the graphs for you, right? You guys remember this in a logging monitoring architecture we discussed? Clear na? This is what we use the node exporter in every node, if you guys remember correctly. Now, in this scenario, we like as any node will come. In this node, you don't want to install manually for again the node exporter. Node exporter, this node exporter, this node exporter, anything again, you guys are feel like this is the node already. We need to install the node exporters. We need to install the node exporter. Even this also will, when the new node will be joined, the will be automatically the node will be create for us. The node will be create for us. That means that application will be deployed in the this here also. We don't need to mention the increase the replicas, nothing else like that. It is the daemon set will be calculate the how many nodes are there, that many parts will be run. That's it. How many nodes will be run, that many parts will be run. We are not worry about that, how many parts will be run. Okay, where are the node you want to run? Okay, it is by default every node will be run. In some cases, you don't want to run the specific node. By some cases, I don't want to run this application in the specific node type. Then what you do, the label we can create, the label we can exclude that. Means in the daemon set we can exclude the what are the node type you don't want to run. That option also we can exclude that, the daemon set level. By default, how many nodes are there, that many pod will be run. That many pods will run, each pod will be run on the every. Clear, guys? Clear now? Now, for example, let's say vi replica set, if we take this, may be okay, will running on the every node, or maybe let me do, okay, let's deploy this, and let's make this into two. Let's deploy the two kubectl apply replica set hyphen apply hyphen f. You must be with hyphen f. Okay, now what happened? It will deploy the replica set 2, right? It will deploy in the two pods. Let's do this kubectl get pods. Okay, this is the running on. If you move wide, if you can see here, and grep, okay, it is, for example, what happened now, you mentioned the two replicas and it will be running on the two here. Okay, then even if you go for the replica set again, and if you mention the, you need to, if you want on the four, if any new node will come up, we are not sure, like, as this will be gone, will be running on the new node, right? Clear or not? Well, like, as it, you mentioned the only two, the two already occupied here. Maybe this pod will down, maybe a next pod may be running on the different node. This is not a guarantee for to run on the each and every node. Let's say, for example, if you're not deployed for anything, let's say if you go for pod, like pod manifest, okay, if you see here, we didn't mention anything. Now what happened, this will create a one pod. It will create only one pod, and then it will running on the any one of the node. It's not a, this pod is not going to deploy in the two nodes, because of how many nodes are there now, right now? kubectl get nodes. If you can see here, how many nodes are there right now? Two nodes are there. Two nodes are there. Clear? It is deployed on the two nodes. These two nodes, this not only master, okay, these two nodes will be there, and means this pod will go and deploy in the how many nodes? Basically, any one of the node will be deployed. Now, if you go for the, you go here, and if you want to deploy this, okay, let's say hello pod 1. There is no hello pod 1. Okay, now what is that? Hyphen, not underscore. Now see, this is the only one will be running. We didn't mention the replica set. Okay, that's the reason it's running on the only one, right? Means it's not sure, like, as which node will gonna deploy. Either one pod will be running on the either in one of the node which is available, right? If one more new node will come, it won't deploy, and this pod will go deploy. But some scenarios, some requirements, you want to run how many nodes are running, how many, that many pods you want to be run. How many nodes are running, that many pods running, and every node you want to run this pod. Then next, what we do, how we are going to using this daemon set. Now, if you use this daemon set, okay, if you use this daemon set, how many nodes are there? Each node, this pod will be going to deploy. How? Let's see that. Understand the requirement, guys. The pod replica set and then this daemon sets. Very very important to the question. They will ask like, as I want to run an application running how many pods are each node I want to run the one pod. Clear, guys? Each node I want to run the pod. Guys, fast. Understand or not? Just let me know again. I'll explain. Okay, simple as that. Basically, if you want to run the application the multiple times, we use the replica set. That replica set we are not sure, like, as where should be run. This is not a guarantee to deploy in the every node. Okay, but in case you want to run the application, that application is a mandatory run on the every node. Every node we are not using a replica set, and in this scenario we are using a daemon set. Like, as every node, how many nodes are running, that many application will go and apply. If any new node will come, even you don't need to redeploy anything. It's automatically will be spin off the new application. Right now, there is a three nodes, like a three daemon set parts will be run. There is a two more nodes added. Then five daemon set will be running. One more node will be deleted. Four daemon set will be running like that. Okay, understand, guys? Clear now? Let's do the practically, and you will understand more knowledge around this. Let me do the hands-on. Let's see the theoretically first. Daemon sets. See, a daemon set ensure that all, like, as are some nodes a copy of a pod. Okay. Now the daemon is like ensure that all the nodes are, and maybe some nodes you want to exclude, you can do that also. As a node are added to the cluster, the pod are added to them. Okay. As node are removed from the cluster, those pods are garbage collected. Deleting a daemon set will clean up the pod it's created. Some typical use cases on daemon sets are running a cluster storage daemon such as a cluster ID, CEFH on each node. Running a long collection daemon set like as a fluentd, file bit, and running a node monitoring daemon every node such as a Prometheus, node exporter, flow will, sysdig agent, collect d, dynamo trace agent, abdynamic agent, datadog agent, new relic agent, ganglia, okay, gmod, insta agent, elastic metric wait, all those, like, as these are the kind of agents which need to be running on the for your monitoring purpose. Another good example for Kubernetes is the QB proxy. This QB proxy is the one kind of daemon set. If you, for example, if you can see here, if you can observe here, Q proxy, the Q proxy and wavenet, these two are the daemon sets, because this networking purpose, this network is the to run the every node, that is a mandatory for us, and Q proxy also, this should be running on the every node. Is it clear now? This should be running on the every node. The Q proxy, what it will do? The Q proxy assigning a IP address to the every pod. It's kind of a, it can manage the simple load balancing as well in between the applications inside your node. Understand now? This is the Q proxy should be running on the every node. We didn't mention that Q proxy running on the only this node on that node. While installing this Q proxy also will install that Q proxy they mention as a daemon set. This wavenet also has a one daemon set. This wavenet also has a one daemon set. That's the reason. Now, by default, as of now, our default namespace, we don't have any daemon sets. Let's deploy for the one application as a daemon set. Okay. Now see, this is the example. If you can see, both replica set or replication controller are running on the specific number of pods and deployed anywhere in the Kubernetes cluster. If you want to deploy in the every anywhere in the Kubernetes cluster, what you do, you can deploy like this. Okay, like as let's see here, replica set. This color will be a green color will be replica set. Like as you want a number of 5, then this will be running here, 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 here. I'm not sure like this will be running on this node or not. And the daemon set exactly one replica on every node. Like as one replica will be run on every node. It's not a it's not a you don't need to mention that running on the 4 or 5. Okay, how many nodes are there? It will be automatically the pod will be deployed in the each node. If a new node will come, that new one more pod will be deployed in the new node. One new node will be deleted, that one existing node will be deleted, then the pod will be garbage collected automatically. Understand, guys? It won't go and create a two more pod in the different another node. Okay, that means now there is a right now there is a 3 nodes are there. One node will delete it. That means it's deploying only two pods only. Two pods only. It's not a no need to go and create one more, because this if you replica set will be like that will work. If the node will go down, if you mention the 3 applications and one is run here, one is run, one is here, if anything this node will go down, this part will go and will spin up the different node. When you go for replica set, when you go for replica set, when you go for daemon set, the daemon set, if the node will go down, then gone, that application will daemon, like as garbage collected. The two nodes are running, two applications only will be created. Two nodes will be running, two applications only will be running. Let's do that. Let's do the practical, and then you will get more understanding on this. Understand, guys, as for the diagram. And let's see, you can read this theoretically. It's the same like what we discussed. Now see this. Okay, let's do this. Daemonsets.yml. Now in this here, I'm gonna deploy for node exporter namespace. We already have a monitoring namespace. Let's what I'm gonna do. I'm gonna do deploy this into the logging monitoring space. My namespace is the logging here. My namespace is the logging here, and the spec is kind same like as same like how the replica set is there, right? The same here. The same here. How the replica set look like the right? The same here. The same replica set manifest, but the simply the change will be the daemon set. Only daemon set here. Replica set will come, and then replicas will count here. How many replicas? But that is the only not come here. Remaining things all as it is the replica set manifest here. Clear now, guys? This is the spec, and then this is the like as labels and selectors and templates, and the spec and the container like an image name, and then application ports. This node export is the image, the Prometheus image, that which we are running on the every node, right? This is image will be downloaded from the like as official page. Clear, guys? Clear now? Any question in this? No, this is the kind is the demand set. Kind is the demand set. D is the capital, S is the capital. Okay. And save this. Save this. What you do? Let's kubectl. Is it works or not, guys? It will deploy or not? Just guess it. Not guess it. Confirm it. It works or not? Any error will come. Right? Why happened? This namespace is not available. Okay, this namespace is not available. Let's create a namespace. Kubectl create namespace. Namespace is the login. Now kubectl get pods. Now all grouping, like as you know, even this logging also go for the monitoring namespace. Just to make sure for you guys are more clarity purpose, I creating this kubectl get pods. I get namespaces. See this. This is the logging namespace. Just 20 seconds ago we created. Kubectl get pods of n logging namespace. Nothing. If you go for mounting namespace, we have a one application. Clear now? This is the previous. This mounting is the previous namespace. That is the one. No, one pod is running. Now these logging namespaces we don't have running. Any pod is running. Now what I'm going to do? I'm going to apply for again the same application. Demand set example I'm deploying. This time this node exporter will be created. And are you mention anything for running a two pods here? Anywhere you mention, I want run this node exporter into the two places. Do you mention anywhere, guys? I want run the two pods for this node exporter. Do you mention anywhere? Anywhere we mention? No, right? We didn't mention the anywhere to run the two pods. Then how many pods is created? Kubectl get pods -n logging, the logging namespaces. How many pods are created? Two pods are created. Now why is the two pods are created? Because of we have a two nodes. Because of we have a two nodes. Let's create a one more node. I'm taking my EMI. This master I'm gonna take. You know, this T2 micro is enough for me. Okay. 8 GB, tax fine. This security group, I'm gonna select it for this case level 32. This is the same security group I'm allowing for this also, because I don't want to create a new security group. I'm gonna attach for existing security group for whatever my slaves are I have. Okay, and then which is the key? Select the key. One more node is created. One more new node is gonna added here. If you want to join this node while building, you can use this data in the user data. Okay, you can add this kubectl join command. Okay, the kubectl join command, where it is kubectl join command. This one, right? You should copy this command. If you, for example, let's say, sir, I forgot to take this kubectl join command, sir, how do you get this? I'll show you. Wait. We have backup of this kubectl join command, right? Even if you forgot to take this backup. Okay, where you need to run this? Sorry, I canceled here. Where do you run this kubectl join command? You need to run in the node, right? Go for the node, connect the node, slave 3, connect the slave 3. Copy this, go for slave 3. The name is Ubuntu by default user. When you create a through image, it will come as a root user. This kubectl join command. Okay, this need a sudo. Now earlier, how many nodes are there? Kubectl get nodes. 2 nodes are there, right? Now Wait for a minute. Let it come up this node. Once this come up, how many nodes are there? How many daemon pods are running now here as of now for us? Oh shit. Two, right? Two pods and two nodes. Still two nodes. One second. Why this much time taking, man? If you want to get the giant command, no, this is the command. Kubectl create token, print giant command. Kubectl kuberium token create giant command. Now this giant command will be create for us. The same, I think so, right? That's a different. Let me execute. Maybe this is the new one which I created. Right? Let me execute this. Bits. Maybe this token may be expired. Let me get this new token. I create a new token. No, it's working. The token is expired, which is taken back up. Now kuberium token create -hyphen print giant command. Now if you do this, this giant command will become in the master node and we can add into the your slave node. Now that's done. The node will be ready. This third node, and let's check that how many nodes are running right now. Now there is a three nodes. These are just recent node it is. And how many daemon sets are running previously? If you go for daemon sets, how many running guys here? How many parts is running node exporter ones? Two, right? And now let's see now. Let's see now. How many should be run now here in this case? Tell me. Two or three? Two or three. Are we deployed any new application? Are we restart the application? Are we increase the replica set? Are we did? No, right? Now see this. If you can observe, this logging is the one daemon set is running. This is the three. The currently three is running. Ready is three, and then available three. Now 7 minutes back is deployed. Is it clear, guys? Is it clear now? Understand the concept, guys. Understand this daemon set concept. In case this is got deleted, let's think about that. Some node got deleted. What I'm gonna do? I'm gonna stop this. I'm stopping this. Now, if you can observe now previously, if you run the pods, see the one node, right? 50 and 120. Which one is gonna down now? 50. This 50, 50, 50, 50. All the pods, whatever the pods are running on this node. See, oh, 2, 3, 4, 5, 6, 7, 7 pods totally is running in this node, like different applications. Now that will go down. Yes or no? If you stop the slave 2. See, this is the down. And what I'm going to do, let's deploy the kubectl get pods. If you can observe now see here. Uh, Maybe it's not at spin up actually. Still, it is there. But it's not able to access. What happened in this case? In this case, what happened? This pod will be still in this node, but this application will be go down actually. It's not able to access. It's not able to access in this scenario. In this scenario, it's not able to access. Now, if you want to remove this completely, if you want to like as undeploy all these pods in the specific node, how we can do? How we can do? I'll tell you that different. Okay. In that there is a scenario called as uncardan. We need to do cardan, uncardan. Cardan command we can use. We can deploy this all the pods into different node. All the pods into different node. We can spin up this. What are the pod is running? That node, in that node, how many pods are running? Those pods will go and spin up this another node. This what is the slave 3 IP? Is a 241. One second. In this namespaces, all those running, no? Many applications running. It will be very confused to reply. Okay, anyways, that's fine. Now what I'm gonna do, let's do get pods and daemon set here. Okay, let's say daemon set. Now see here, what happened is earlier how many is running now? How many earlier it's running previously? 3, right? Now how many running? 2. If you stop, then that pod will go down automatically. Okay. Then when I start this again, then what happened? That will come up automatically first. That is the daemon set, beautiness of the daemon set. That is mandatory interview question also. When you go for interview, they're gonna tell you. Sir, tell me some scenarios. Some guys will be there. Okay, in the interview, they will ask you, Alright, okay, fine, man. I am understand, like as you explained, daemon set should be running on every node, but by some cases, I don't want on the specific node type. How you exclude that? They will ask a scenario based question. Understand, na? Guys? Understand the concept? Now, by default, running on the every node, but the interviewer won't be simply ask the simple questions, no? They should test you your in-depth knowledge, okay? They will test you your in-depth knowledge, or you know that all the scenarios or not. Now they will ask you the question. If you're really working, then you will get to know definitely this concept. If you're not working, just learning and taking a training, you will understand only for until daemon set concept means okay, running on the every node. That's it. Now, how to exclude on the specific node and all? How do you mention? You need to explain for that. Okay. How we can mention? Now, this is a daemon set, just even though I mentioned. And if you can see here, observe here, this concept. Okay. Now, if you can see node selector disk SSD. SSD is the label, okay, one of the label. Okay, this is the label. Now, if you can observe SSD, 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 and it's not SSD node, and that's the reason this pod will not be created on this. This daemon set is not created this node. You guys are seen here. What need to explain? You need to use the node selector. What is the option? Node selector. We need to option we can use inside the daemon set. I'll show that how to use. Let me show in this. Now see, this is the node selector, the concept we used. Where we need to add this, I'll show with the manifest. Wait a minute. Now see this node selector, this is the disk, this is the label is the disk is SSD, disk is SSD, disk is SSD contains. Now the next, this pod is like pod monitor running on the only where the SSD is available, but there is no S like label is the SSD. Then that's the reason the DMAR set is not created under this node. Only specific label. Okay, in that scenario, what you do, you can include that. You can include that in the manifest. How do you include that in the manifest? Let me demonstrate. And if you can see here, this one in the spec before container in the spec node selector disk SSD. This SSD is the one of the label. The disk type. What are the SSD disk type is there that will be deployed. This SSD is the disk type, and that will be deployed. What is the disk type? SSD disk type. Basically, as of now, we every node is an SSD only. Now, what is means like basically SSD disk type and all. When you launch the instance, this is the one I think so. Uh, 1 second, just cross check once. This is the one which we are taking SSD disk type, and we have a different types here, like as you know, SSD, GP2, GP3, right? These all are SSD only. Okay, these all are SSD only. Okay, this is the SSD only. Maybe if you have the different types, you can do. Or else we can do create a labels and then we can add the labels also. I mean, again, it will be a big movie again. If I take that way, you guys are not understand. Okay, simple guys. Okay, let me show this. This is for what happened. This is a include type. Include type means if you the node contains disk SSD type, it will deploy the only SSD type nodes. Is that clear now? This is the include. This is the include type. Node selector. Node selector. You need to tell the interview question. In the interview ask, you can mention the based on the node selector and node selector name. We can deploy in the specific node. Is it clear now? And some cases they will ask, okay, I have all the nodes selected, only one I don't want, like let's say same in the Ansible we discussed now. Okay, let's say what concept, tags, right? Tags, -f tags, or -f skip -tags. You remember in Ansible? No, the same way here, like this is whatever you want, you can use this here, SSD. Even exclude also. Exclude also will be there, I think so. Let's see. If we see official document, even you can mention the resource also, how much this pod is needed to resource. We can request the resource and the limit maximum we can use. Okay, you can maximum you can use. You can mention this, how many resources you want also. This is the persistent volume logging. Okay, this is a logging concept. We'll discuss in the further. What is the volume mounts? Okay, this volume mounts anyway. Next section, the config maps, that time will come. Okay, and we'll discuss this in the persistent volume. That's No, definitely. Taint and tolerance. What we can do? Uh-huh. This no, definitely. If the required during the scheduling, ignore the during execution. If you want, ignore the specific node. If the node selector to match field, key, metadata name, operator in values, target host name. Okay, this again. Independent. What they do, this specific node only if it there, then only we can do this. The values means the specific host name. The host name only you want to deploy, you can apply the specific host name also here. You can use this node affinity. We'll discuss this node affinity concept again. This is a different concept. Node selector. This daemon set only not only node selector. This can work for the anywhere. Okay, pod, replica set, everywhere. This spec we can add this node selector. It's not only daemon set. You can use this spec in the anywhere in the any manifest. The replica set you can use, deployment you can use. Okay, and you can apply the specific node type. Understand now? If someone will ask and a specific node type I want to deploy, you can mention the using the node selector. That is the one option we can use. Node selector. You can say this answer. There's more than enough. Okay. What is this node selector and all means? Will I explain for the another scenario? Okay. Node affinity, node selector. Again, the specific node type you want to deploy, you can specify this in a your container manifest. Okay, like I mean in this here in this spec, at the node selector and then container before the container manifest, you can use this inside the spec. Clear now? But here we didn't mention anything. It will apply in the every node. In that case, it will apply in the every node. Where it is here. Now you can see now it will be again that node is started. The three pods will be created, right? Now if you can see earlier, this also earlier if you can see Q proxy, wavenet. Earlier how many it is running basically? 3 is running, right? Now it's a created 4. Means this also has a daemon sets, right? That also will be created and running on the that new node automatically. How many nodes are coming? This cube system, cube wavenet, and then this node exporter will be running on the every node. If you create 20 nodes attached to this okay, cluster, 20 times it will be created for us. Yes, these two are including master, but this is not including master because this application and this is the this is for your network and your master node component. It's a master node component. That's the reason it's coming with the one extra pod, one extra pod. Understand, guys? Understand this? That's the importance of daemon set. Okay, and this is the rare cases we used only one scenario. Okay, in real scenarios. Okay, this is the one. Any logging, any monitoring, anything you want to deploy, we can use the daemon sets. Not for entire applications. Okay, application level we won't use. We use the replica set. But this is the daemon set should be running on the every node place. In that scenario only we use this. Axiom log collectors. Let's say fluentd node exporter. In this scenario only we use the daemon sets. Clear, guys? Understand the demand set concept? Guys, are you guys are there? Guys, can you hear me? Hello? Yeah, man. Bye, guys. No response. Are you guys understand the demand concept? It's a very, very important for interview point of time. Okay, that's very, very important. But and then next concept, what we do, we'll go for job and cron job. Job and cron job. It's a very simple. This also when we used to. It's a simple case, same kind of a pod. Okay, and these are all not running like a pod. Pod will be continuously running. The job and cron job, what will do? It will run and it will stop automatically. Understand? No? Once, like for example, you want to check something, you want to find something, okay, something, just simply you can run the job and then terminate the job automatically once it job is complete. It's a kind of console application. It's pod is kind of a web application, let's say, like as in a simple hello world class, and this is servlet program kind of. Again, that is a Java, right? Simple. The continuously running application is different. Simple go on check something is different. Go on check. Once the job is complete, then the pod will go down. That scenario we can use this, and this is only one time. Multiple time you want to do, we can use this simply. That is the concept we are using. Understand? Na? Job and cron job. What's the time? Right. Okay, let's we this concept will explain for the practically tomorrow. Okay, and simply understand the concept today. What is a job? Okay, execute some program and completes the program. Anything, whatever the process, whatever the program it is done, it completes the program, and then it will come out. It's come out from that. It's come out from that. Means it won't run the completely. It won't run the continuously. It is just run, it will came out. And the cron job run the multiple times. Now let's say anything, any pods are running, any nodes are running, the service is running or not. You want to check. You want to check, it will notify or something. That job is running every 1 hour, let's say. Every 1 hour automatically run. Then we can use the cron job. Both are comes under the this will batch group, batch API. These two comes under the batch API. Job and cron job come under the batch API. Understand? Na? Okay. Any questions, guys? Any questions? And this we'll discuss tomorrow. Okay. And day after tomorrow we'll discuss about the config map and config map and secrets. And a secret real-time use case also we'll discuss. Real-time use case, this is the mandatory. Config map and secret is the mandatory for every application we are using. Okay, that listen tomorrow and day after tomorrow. It's a very important. Don't miss the classes. Okay. And from Thursday, Friday, Saturday, Sunday, Monday, I'm not available, guys. Okay. Next, you guys also plan according that if you want to go for festival or whatever. Okay. Next class will be 18th. Next class will be 18th. Okay. We have a class tomorrow, day after tomorrow. Okay. We have a class for 10 and 12. Fine, guys. Then see you on a tomorrow class. Bye. Bye, guys.